Welcome to EducAgent Studio, where a crew of AI agents help us teach, and you learn with ease. Here's the problem we'll solve today. Suppose you performed Gaussian elimination upwards instead of the usual downward elimination. Starting from the last row, use it to create zeros above the pivot in the last column. Here the pivot is 1. Then use the second row to create a 0 above the second pivot. For A equals the 3 by 3 matrix shown, find the factors in the unusual order A equals UL, where U is upper triangular and L is lower triangular. On the left is the standard picture. Clear entries below each pivot. On the right is today's twist. We clear entries above the pivots, starting from the bottom right pivot and moving upward. Upward elimination corresponds to multiplying by upper triangular elimination matrices on the left, until the matrix becomes lower triangular. We start at the last pivot, A33 equals 1. Our goal is to eliminate the two entries above it in column 3. Subtract row 3 from row 1 and row 2 to create zeros above the pivot in the last column. Now column 3 has zeros in rows 1 and 2, and we keep moving upward. This is captured by an upper triangular elimination matrix E3 acting on the left. Next pivot is a 2, 2 equals 2. We eliminate the entry above it at 1, 2. Subtract row 2 from row 1 to force a 1, 2 to become 0. We've reached a lower triangular matrix. This will be our L. The second upward elimination step is another upper triangular elimination matrix, E2. Combining both moves, first E3, then E2, we get a single transformation of A. The product E2-E3 turns A into this lower triangular matrix L. Rearranging gives the unusual order factorization, A equals UL. The multiplication shown on screen simplifies exactly to the final matrix on the right, 1 minus 1, 0, 0, 1 minus 1. We'll name that product E and invert it to get U. Read each minus 1 above the diagonal as a subtraction of the row beneath it. To invert, we reverse the order and switch subtraction to addition. That produces a unit upper triangular U. These are the two triangular factors, U from undoing elimination and L from the final eliminated form. Multiplying U and L reconstructs A, so the factorization checks out. Upward elimination builds a product E2-E3 that sends A to a lower triangular matrix L. The inverse of that product is the upper triangular factor U. The key idea is that switching elimination direction switches which triangular factor comes from elimination and which comes from inversion. Watch the next video to see how these elimination matrices generalize and how different elimination strategies create different but equally useful factorizations.